Hello students, welcome to my channel Engineering Education. Please subscribe my channel. Thank you. In this lecture we are going to solve problem 2.11, chapter number 2, the working fluid, from the book Applied Thermodynamics by Eastop and McConkey. Statement of the problem is: an air compressor of the pressures at the inlet and outlet are 1 bar and 5 bar respectively. Temperature of the air at inlet is 15 degrees centigrade and the volume at the beginning of the compression is 3 times that at the end of compression. Calculate the temperature of the air at outlet and the increase in internal energy per kilogram of air. So let's suppose if we have a block diagram of the compressor. Suppose this is the inlet and this is the outlet. So at inlet we designate the properties with state 1, and at outlet we will designate the properties with state 2. So here the pressure is P1, volume here is V1. Similarly, the temperature represented here is T1. Also here we have pressure P2, volume V2 and temperature T2. This is the inlet and this is the outlet. So if we write the given data according to the designated properties at inlet and outlet, so we have given that pressure P1 is 1 bar and pressure P2 is 5 bar. Temperature T1 is 15 degrees centigrade. So if we convert it to Kelvin, it will become 288 Kelvin. Also, the volume at the beginning of the compression is 3 times that at the end of compression, meaning that V1 is equal to 3 times of V2. So we are required to find 2 terms in this problem. First, we will find the temperature of the air at outlet, that is T2, and second we have to find the value of increase in internal energy per kilogram, means that change in internal energy U2 minus U1. So first of all we will find the value of T2. So for that we will need the characteristic equation of state at inlet and outlet. So the general equation is PV is equal to mRT. Also, if we write this equation for state 1, it will become P1 V1 mRT1. Also, we can write that for state 2, this is for state 1 at inlet, and if we write for state 2, it will become P2 V2 is equal to mRT2. So this is for state 2 or outlet of the compressor. So further we can rearrange this and can write it like this: mr is equal to P1 V1 over T1. Also, if we rearrange this, it will become mr is equal to P2 V2 over T2. So let's suppose this is expression A and this is expression B. As we see that left hand side of this expression A and left hand side of this expression B are same, so we can write that the right hand side of A will be equal to right hand side of B. So we can write that P1 V1 over T1 is equal to P2 V2 over T2. Further, if we rearrange it for T2, so it will be equal to T2 is equal to P2 V2 over P1 V1 into T1. So all terms and properties are given, only T2 is unknown. So T2 is equal to P2 is 5 bar and the value of V2 is 1 by 3 of V1, or we can also it like this, only V2. Further, the value of P1 is 1 bar and the value of V1 is 3 times of V2, so it will be written like this, and the value of T1 is 15 degrees centigrade or 288 Kelvin. So simplifying this, we will get 5 into 288 over 3. So solving this, we get the value of T2 and it comes equal to 480 Kelvin, or in degrees centigrade it is 207 degrees centigrade. So this is the solution of part 1. In part 2 we are required to find the increase in internal energy per kilogram. So U2 minus U1 value is required. We know that if we assume the state 1 and state 2, so for state 1 the internal energy from the Joule's law will be U1 is equal to CVT1, and for state 2 U2 is equal to CV into T2. So if we combine these two terms in one expression, it will become U2 minus U1 is equal to CV. CV will be common in both T2 minus T1. So this will be the change in internal energy, or it will be the increase in internal energy. So CV value is given in the start of the problems, that is 0.718 kilojoule per kilogram per Kelvin. So if we put the values, CV is 0.718, the value of T2 is calculated here, that is 480, and the value of T1 is 288. So simplifying this, we get the change in internal energy, or the increase in internal energy, 1388 0.8 kilojoule per kilogram. So this is the required solution of problem 2.11. Thanks for watching. Please like and comment on my videos. Also subscribe my channel to get new videos.